You are welcome to Physics Clinic. In this video, I will be discussing photoelectric effect. When light or electromagnetic radiation of high enough frequency is incident on the metal surface, electrons are ejected. The ejected electrons are referred to as photoelectrons, while the phenomenon is called photoelectric effect. To understand photoelectric effect, I would like to describe an experiment. Here, we have a gold leaf electroscope. On it, we have a zinc metal plate. The zinc metal plate is cleaned and placed on the gold leaf electroscope. And the surface of the zinc metal plate is full of mobile electrons, so it causes the electroscope to be charged negatively. Then, we allow visible light to be incident on the zinc plate. So the visible light of a particular frequency is incident on the zinc plate. And our observation shows that nothing happened to the gold leaf in the gold leaf electroscope. Then we increase the intensity or brightness of the incident visible light. Still, nothing happened to the gold leaf. Then we replace the visible light source with ultraviolet light source, and we use the ultraviolet light to incident on the zinc metal. The moment the ultraviolet light source incident on the zinc metal plate, instantaneously electrons are seen jumping out of the metal surface, and as a result the leaf collapses, indicating electrons are leaving the gold leaf electroscope. These electrons are what we refer to as photoelectrons because they are caused to leave the metal surface as a result of light. During the course of the experiment, we came up with some conclusions. The first conclusion is, if photo emission takes place, it does so instantaneously. There is no delay between illumination and emission. So when we have light or electromagnetic radiation of sufficient frequency and we incident this electromagnetic radiation on the metal surface, instantaneously electrons will be ejected. There will be no delay within the time of incident and the time of ejection of these electrons. The electrons are ejected instantaneously. The second conclusion we came up with is photoemission takes place only if the frequency of the incident radiation is above a certain minimum value called the threshold frequency. So during the course of the experiment, we discovered that the frequency of the incident radiation must be greater than a minimum value before electrons will be ejected from the metal surface. Once the frequency of the incident radiation is less than the minimum value, no electrons will leave the metal surface. But once the frequency of the incident radiation is equal or greater than this minimum value, electrons are seen to be ejected from the metal surface. So this minimum frequency that is required for electrons to leave the metal surface is what we refer to as threshold frequency, symbol F0. Number 3 conclusion: different metals have different threshold frequencies. So for different metals, we have different value for threshold frequencies. So zinc, for example, has its own particular threshold frequency, and that is different from other metals. The fourth conclusion we have here is that whether or not emission takes place depends only on whether the frequency of the incident radiation is used is above the threshold for that particular surface. So what determines if electrons will be ejected from the metal surface is the frequency of the incident radiation. Once the frequency of the incident radiation is equal or above the threshold frequency of that metal, electrons will be ejected from the metal surface. But if the incident radiation, if the frequency of the incident radiation is less than the threshold frequency of the metal, no electrons will be ejected from that particular surface. So it does not depend on the intensity of the radiation. So the ejection of electrons from the metal surface does not depend on the intensity of the incident radiation. It depends on the frequency of the incident radiation. The fifth conclusion we have is that for a given frequency, the rate of emission of photoelectrons is proportional to the intensity of the radiation. What we mean here is that if the incident radiation has a particular frequency, electrons will be ejected. Now, if we want more electrons to be ejected per second, we'll increase the what? The intensity of the incident ray. Once the intensity or brightness of the incident ray radiation is increased, more electrons will be seen to leave the surface per second. So intensity determines the number of electrons leaving the surface per second. This is where we're going to be ending the class for photoelectric effect today. See you in next class. Thank you.